Hello, and welcome to this lesson on testing for gases in chemistry. In today's lesson, we will first learn how to test for hydrogen gas using a burning splint. Next, we'll discover how to identify oxygen gas using a glowing splint. After this, we'll explore the test for carbon dioxide using lime water. Finally, we'll understand how to detect chlorine gas using damp blue litmus paper. Testing for gases is a crucial part of chemical analysis because it helps us identify the gases produced during reactions. By knowing which gas is released, we can better understand the reaction itself and the substances involved. Now, let's look at the different tests used to identify common gases. To test for hydrogen gas, you will need a test tube containing the gas you suspect is hydrogen. The setup for this test is very straightforward. First, ensure that the test tube containing the gas is securely held in an upward position. Then, light a splint. It's best to use a wooden splint for safety and convenience reasons. Once your splint is burning, carefully bring it to the open end of the test tube. Hold the burning splint right at the mouth of the test tube, where the gas can interact with the flame. If hydrogen gas is present in the test tube, you will hear a characteristic pop sound. The sound is a clear and distinctive indicator of hydrogen gas. The reason you hear the pop sound is because hydrogen is a very flammable gas that reacts quickly with oxygen in the air. When you bring the lit splint to the mouth of the test tube, the hydrogen gas mixes with oxygen and ignites, causing a small, rapid combustion reaction. This reaction produces water in the form of vapor and releases energy in the form of heat and sound. The energy from the reaction is released very quickly, which causes the gases to expand rapidly and create the characteristic pop sound. To test for the presence of oxygen gas, we use a glowing splint. To prepare the splint, we light a wooden splint using a flame and then blow it out so that it is just glowing at the tip. The splint should not be burning with a flame but should have a glowing ember. We then gently place the glowing splint into the test tube containing gas, ensuring that it does not touch the sides or the bottom of the tube. This ensures that any reaction is due to the gas within the test tube and not due to contact with the glass. If oxygen gas is present, the glowing splint will relight, meaning it will catch fire again. This happens because oxygen is a supporter of combustion, and the increased concentration of oxygen in the test tube will cause the glowing splint to reignite. To test for the presence of carbon dioxide gas, we use lime water, which is a solution of calcium hydroxide in water. Lime water is used because it reacts specifically with carbon dioxide in a way that's easy to observe. To carry out the test, you can bubble the gas suspected to be carbon dioxide through lime water. This is often done by using a delivery tube, which directs the gas from the reaction container, where the gas is produced, into a separate container filled with lime water. Another method is to shake the gas with lime water in a sealed container, allowing the gas to mix with the lime water. In both cases, if carbon dioxide is present, it reacts with the calcium hydroxide in the lime water to form calcium carbonate, which is a white, insoluble solid. The calcium carbonate forms a fine, white precipitate that makes the previously clear lime water turn milky or cloudy. This cloudiness is a clear and reliable sign that carbon dioxide is present. This test is commonly used in experiments to confirm the production of carbon dioxide gas, such as in reactions involving acids and carbonates, or the combustion of carbon-based materials. To test for chlorine gas, we use damp blue litmus paper, which we carefully place into the container with the gas. If chlorine gas is present, it will cause the damp blue litmus paper to turn white. This process is known as bleaching. The reason this happens is that chlorine is a strong oxidizing agent, and it reacts with the compounds present in the litmus paper, resulting in a bleaching effect. It's important to note that chlorine gas is highly toxic and can cause serious respiratory issues if inhaled. Therefore, when testing for chlorine gas, make sure to conduct the experiment in a well-ventilated area, or, ideally, in a fume hood to prevent exposure to the gas. Safety precautions should always be followed when handling chlorine. Let's now work through some examples to consolidate our knowledge. Example 1. A chemical storage area has an unknown gas leak, and there is concern that it might be chlorine gas. As the safety officer, you need to identify if the leaking gas is chlorine. Describe the steps you would take to test for chlorine gas. The answer: collect a small sample of the gas in a container. Use damp blue litmus paper and carefully expose it to the gas. If chlorine gas is present, the blue litmus paper will turn white due to its bleaching effect. Example 2. You are working in a laboratory and need to test if a gas produced during a chemical reaction is carbon dioxide. Describe the test you would perform and the result you would expect if carbon dioxide is present. The answer. To test for carbon dioxide, collect the gas produced and bubble it through lime water using a delivery tube. If carbon dioxide is present, it will react with the lime water to form calcium carbonate, causing the clear lime water to turn milky or cloudy. Finally, example 3. During a demonstration in class, your teacher has a container of gas and wants to show that it supports combustion. They perform a test using a glowing splint. What gas are they likely testing for, and what observation would confirm the gas's identity? The answer. They are likely testing for oxygen gas. If the glowing splint is inserted into the container and it relights, this confirms the presence of oxygen, as oxygen supports combustion. By practicing these examples and applying the test in real-life scenarios, you will gain confidence in identifying gases. This foundational skill is crucial in various scientific experiments and industrial applications. In today's lesson, we explored 4 common tests used to identify gases in chemistry. We learned how hydrogen can be identified by its characteristic pop sound when ignited, indicating its flammability. We discovered how oxygen supports combustion, causing a glowing splint to relight. We examined how carbon dioxide turns lime water cloudy due to the formation of calcium carbonate. Finally, we saw how chlorine gas can bleach damp blue litmus paper due to its strong oxidizing properties. By mastering these tests, we gain valuable tools for identifying gases in the lab. Watch the rest of the GCSE chemistry course at Sophos Education.